Hi everyone, in this video I want to do a comparison between one-sided test and two-sided test. One-sided versus two-sided test. Okay, so when we are doing, let's say, we are testing whether something's different, right? In this case, we're most likely to test if the value is greater than or less than, right? So both greater than the value we're testing for or less than the value we're testing for, we see them as different. So in this case, we're most often, or not most often, then we're doing a two-sided test. Okay. In fact, most of the testings we do are two-sided tests. Okay. And let's do an example. Okay. Let's say the Cal State University Los Angeles student average GPA, is male, right? Just a number male population for the whole student population, and we want to test whether econ students have a different GPA than the population average. So we want to test whether econ students have different GPA. Okay, so that's our task is to test whether it's different. So if we write out the null hypothesis, right? Mu, I'll just say GPA econ, right? Whether it's equals to. So under the null, it's when there's no difference. When they're the same, with the mu under the null, and then or let me just say mu. Okay. Mu, and then alternative, it's when the econ students' GPA are not equals to the whole school's mean. Okay. So in this case, when we put a not equal sign, means that if the econ student GPA is lower than mu, different. If it's higher than mu, different, right? So both lower or greater than means different, right? So in this case, we're doing a two-sided test, right? Lower than or greater than are both different. So if you look at the normal distribution, if we're assuming this one hasn't been normalized, standardized yet. So then reject if it's lower, reject if it's higher. Then these two are our rejection regions. Right? So as you can see, in a two-sided test, you reject in both sides. Okay? And after you do your standardization, okay. So once you do the standardization or standardized normal, right? Then what we're looking at is 0 in here, and then critical values here, and critical values here. And these two rejection regions, they add up to be your alpha, which is your significance level. And the reason you add up these two from the definition of alpha is that you are going to make mistake in this side and this side, right? So they sum up to be your alpha, which is your significance level. And if you want to see it from the perspective of your p-value, if you're seeing from your perspective of p-value, then your standardized normal, 0 here, your test statistics here, and your test statistics here, and these two areas, they sum up to be your p-value. Okay, and this is how you see a two-sided test, right? You reject from both sides, since lower than or greater than is different. Now let's do it. Do a one-sided test, or let's see. Yeah, let's do one-sided test. Okay, so if we do one-sided test, one example we did was whether naps can help you reduce your homework time. Okay, so the example was whether naps reduce homework time. So in this case, naps can be helpful only if it reduces your homework time. Okay, so only helpful if reduce homework time. Okay, so only helpful if it's reduce your homework time. And let's say your average homework time, say it's meal. Okay, or let me just put a number here, right? 6 hours. Okay, if your homework time is 6 hours, then your null hypothesis again is the hypothesis that nothing changed, or naps are not helpful. So this one's the homework time is greater than or equal to 6 hours. And the alternative hypothesis is when it's helpful, so time is less than 6 hours. Okay, very good. So as you can see, this is a one-sided test, because what makes a difference, or what means to be a different result, is one-sided. It's only when it's less than 6 hours. Okay, and again, let's see from the standardized normal. Okay, so if you see it from the standardized normal, then only when it's less, say critical value is here, so it's only when it's less, you reject your null, so your alpha is only the left-hand side. Okay, and then the p-value, you only look at it on the left-hand side, because you only reject when it's lower. So you test statistics, and this is your p-value. Okay, so you only see it from one side. And yeah, let me just do one more, because this one looks at less than. Let me do it greater than. Okay, so this is example 2. Example 2, it's asking the question whether reading class is helpful or not, right? So in this case, remember the national average was 300, so the null hypothesis mu less equals to 300, so it's not helpful, right? So reading speed is either stay as 300 or less than 300, so not helpful. It's not, it's mu is greater than 300, right? So this one is when it's helpful, right? So your reading speed goes up. Okay. So this time it's Mike's class. Mike's class. Okay, Mike's. And then your alpha, or the rejection region value is on the left hand side. Okay, and then for the p-value, okay, you'll be looking at the right hand side. Okay, sorry, right hand side. Okay, choose that, right? Because you only reject when you observe a bigger value than 300. Okay. So let me just put a final note to finish this video. So whether you do a one-sided test or a two-sided test, it depends on, in your question or in your problem, what counts as different. What counts as a difference are so one-sided or two-sided test, right? Depends on what counts as changes or makes a difference, right? So in your question, what makes a difference is the base they're going to use to determine whether you want to do a one-sided test or a two-sided test. Okay, thank you for watching this video. I'll see you in the next video.